Good evening, everyone. Welcome to the second session of the LaTeX Workshop conducted by ISC Student Chapter Branch of Government Engineering College, Botany Hill. I hope you're all ready to make use of this opportunity to make a fabulous document. I welcome Philip, sir.
Thank you. So good evening to all. So welcome to our second section. So yesterday, towards the end, one of the person asked me how to make a multi-column, or you want to combine certain number of columns and certain number of rows in a table. So I just thought I'll give you an example. So based on our yesterday's information, we have begin table, then we have a begin tabular. In this itself, we can create a multi-row and a multi-column. So in this first example, that is table 1, you can see I have combined the 3 rows, that is where the text is multi-row text. I have combined 3 rows, and where you see multi-column heading, I have combined 2 columns. So the command for this is, for a multi-row, you can give /multi-row, and you can mention the number of rows which you want to combine. And in the second option, you can give a star. The star means it will take the width of the text. If you give something else, it will adjust accordingly. Suppose if you change the width to say 12 point, it will change the text accordingly. You can see. So if you want the column to be exactly of the same width as the text, you have to give a star. Then the third option is, third parameter is your text, what you want to get printed. And in the next column, I have mentioned multi-column. So this is my first row of the table. And for multi-column, it is slightly different. First parameter is the same. You specify how many columns that you want to combine. And the second option is how to align that column. You want it center aligned, right aligned, or left aligned. So I have used center aligned. That is the option C. And finally, at the end of that column, I want that vertical line as well. And in the third parameter, you have to give the column name. And you can see in this row, I have only 2 columns. That is why there is only one ampersand symbol. Okay. So the third column is not specified here because we have already combined those 2 last columns. And then in the second row, I don't have any first column element. That is why I have kept the first column blank. I have started mentioning the second column parameters, second column data, that is data 1, data 2, and same is for the third row. Now you can see there is a problem with this table. Okay, if you have noticed it, there is a width problem. The second column, the third column, the gap is not equal. Okay, I can tell you it's a problem with LaTeX. Okay, creating a table in a LaTeX is little bit tricky, and believe me, so many people have made so many contributions towards making tables easy. So this is one of the problem with using multi-column in a simple tabular. Now you can see the next example, that is table 2. In this, it's okay. The gap is equal. Even all the columns are having equal width. So for this, I have used a different package. I have used the package known as Excel Tabular. Yesterday I have mentioned this. There are a lot of packages. I generally use Excel Tabular. That is why I have mentioned this in this example. So in Excel Tabular, you have one more parameter that you have to mention before starting the table. That is, you have to specify how much width this table is going to take. So the width of the page is mentioned as line width, that is /line width. So I want my table to span 70% of my line width. That is why I gave 0.7 line width. Then in the third parameter, as a third parameter in the columns, in this example, you can see I have used a different C, that is a capital C. Okay. What this is, you cannot use this in a normal tabular. It's not defined. This, this capital C is created by me. Okay, I'll show you that command. See, I have created a new column type, that is C, and I have used the Excel tabula's own version, that is X. Usually, if the capital X is Excel tabula's default alignment. So if I use X, it means it will be left aligned. So I want my data to be center. So that is why I created my own column type. You can also create. I created capital C and I'm using it. So in this, since I'm using capital C, or I should say X, it will create a table with equal column spaces. Okay. Suppose if I change this capital C to small c, you can see that the first column has shrunk a little bit. Okay. If I change it to capital C, it has it is now equal with column 2 and column 3. So this is how you make how you make a table with a different package. The syntax is all the same. The rest of the things are same. Only I have changed my environment, that is Excel tabular. For this, you have to use the package Excel tabular as mentioned. And for the multi-row as well, you have to use the package multi-row. Okay. Now you can see the third table. I have removed the vertical lines. Now you see, for me, the third table is a slightly more better version than the second one. And it's far better compared to the first one. You can see everything is neatly spaced out. Even the columns also, even the rows also are neatly spaced out. So this is using the book tab package. I have used the same Excel tabular version. I have changed the horizontal lines. Instead of H line, I have used top rule. So it will make a slightly thicker top line. And at the bottom, I have used bottom rule, which will create a slightly thicker bottom line. For creating middle lines, okay, I have used C mid rule. And I want this line to span from column 2 to column 3. That is why I have mentioned column 2 to 3. Same is for the other table, that is C line. If you are using book tab, you can use C mid rule. If you are not using book tab, you can use C line. That is a default option in the LaTeX. So it's the same. So are you clear? So we'll move on to this today's presentation. So we'll start with mathematical equations. This is very important. Anyway, you are in your college or maybe in your MTech, or when you're doing PhD or anywhere, you may end up in writing lot of equations. Take a look at this example. You can see it's a very big equation. It will take a lot of time in making this equation in Word, I should say. But in LaTeX, it's simple. Anyway, you have to type everything. You have to specify the square root, sine, integral, everything. You have to mention it. But the way you type it, it's very easy. It's not like you have to click anywhere. You just have to keep on typing. You'll have, you should have a figure in mind, what kind of equation it is, and you just have to keep on typing. So we'll see how it is done. Now this is where I introduce you to the math mode. So this is used to write equations and simples like the one I have shown above. So you have three options to get into this math mode. The first one is using a single dollar. You begin with a single dollar and you end with a single dollar. Whatever you write in this will be in math mode. The second option is You begin with slash square brackets, that is left bracket, and you end with slash right bracket. Or you can use a double dollar. Both are the same. The third option is you can give begin equation and end equation. Now, there are many more methods which you can use for entering into math mode, but these are the basic ones. And now we'll see what are the differences. The first example using single dollar. Now you can see on my right side, I have written alpha plus beta is equal to gamma. And you can see it is left aligned. What this means is if you want to type the equation or whatever simple or anything in line with your text, that is in between when you're writing a paragraph, in between you want to mention an alpha any symbol, you have to use a single dollar. So that will print along with the line. Now, if you want that equation or anything you want in a new line, you have to use the second option, that is square bracket or double dollar. The command is the same, only that environment is different. Now the third option is you can use begin equation. Now you can see the difference between the second option and the third option. The output is the same, but you have a number 1 at the end of it. So it will automatically create an equation number for you. Now, if you don't want that number, but you still want to use begin equation, you can use begin equation star, okay, like our chapter star, section star, likewise. Okay. So for any Greek symbols, that is alpha, beta, gamma, whatever it is, have to, it is all there in that. You just have to give that command, that is slash alpha. When you're using TechMaker, this will pop up. When you start typing slash a, it'll suggest you whether it is alpha and whether you want alpha or something else. So you have to just type and fill it in. Now, now if you want to type percentage, ampersand, brackets, curly brackets, I mean, it's all part of LaTeX commands. So it's difficult to if you just simply type percentage, it'll create a comment. So you have to escape that character. That's why we give a backslash and then the percentage symbol. You can either write it in math mode or you can just simply write backslash percentage. Same is the case for the rest of the symbols, but you can see there is a slight difference in the output, at least for that percentage and the ampersand. If you see the output, it's in the math mode, it will create something which is similar to the numbers. In presentation mode, I think it looks a little different, but in your report and article, it will have a huge difference, I feel. So in ampersand also, for in math mode, it's the curves and all, it's slightly different, but for the brackets, it's the same. Just for your information, I have printed this. Now we have coming to little more features. We are going to use package called AMS Math. So I suggest you to use AMS Math whenever you start using equations or whatever it is, symbols. Okay, AMS Math is not for the symbols, but it's for the align command. There are many more commands in that, but for the align, using this AMS Math. So what this aligned environment means is, if you're having a multiple equations and you want that equations to be aligned, say for this example, I have aligned all the equal to symbols at the in the same column. So to align that, you're using the ampersand symbol. You can see here, I have used the ampersand symbol before the equal. I have placed it for each and every equation. And to get into the next equation, I have put 2 slashes to go to the next line. Okay. So as you can see, different symbols. I have tried to cover almost all the symbols here. Not all, but at least some of the symbols which you use regularly. Omega, capital Omega. And if you want a subscript, you have to give an underscore and you have to write whatever you want as subscript in the curly brackets. If you want a superscript, you have to give an exponent symbol and then you have to write your superscript text in the curly brackets. If you want a division symbol, you have to give slash div. And if you want the multiplication symbol, you have to give slash times. Now, in this example, you can see in the using the align environment, for each equation number is printed. That is 2, 3, 4. You can see it is a continuing number. It is automatically incremented. The earlier equation was 1. Now it is 2, 3, 4. Now you can see there is there's hardly any space between the symbol and the equal to sign. So it's fine. There is nothing wrong with it. But if you want to add more space, you cannot simply type space. Okay, in LaTeX, how many spaces if you give, it will always take it as a single space. So if you want to add more space in math mode, okay, you have to give slash quad. So I have given space on either side of the equal to symbol. There is a quad on the left side of equal to, and there is a quad on the right side of equal to. Okay. Now, if you want to use the align environment, but you don't want an equation number for a particular equation, you can always give slash no number so that the equation number won't be printed for that equation. It's very simple. There is nothing to think about it too much. Now coming to fractions, you have 3 options to represent fractions. You have the slash dfrac, you have the slash frac, and tfrac. I always suggest you to go for slash frac. Okay. I'm trying to show you what is the difference between frac, dfrac, and tfrac. Dfrac means if you want to put the equation on a separate line and you want the equation to be centered, dfrac should be the option. If you want the equation to be in line with the text, that means if you're using a single dollar and if you want to represent a fraction, you have to use tfrac. But remembering these two things will be difficult. So LaTeX is providing you with a common command called frac. It will automatically take care according to your math mode, the single dollar or double dollar or whatever it is, it will print accordingly. In this example, this frac has taken the form of dfrac. I have not mentioned the other example. If you can try it on your own. If it is in line with the text, it will take tfrac. So you can see that the tfrac output is slightly smaller, just to be in par with the line, the text line, the text. Now, if you are going to use align and you don't want numbers for any of the equation, you can still use align star. Okay, there are a lot of options for math. Actually, that is the most interesting feature of one of the most interesting feature of LaTeX. There are a lot of options for math mode. Now, if you want to print square root, it's very simple, slash sqrt. And if you want to print cube root or nth root, you have to specify sqrt, and in optional bracket, that is square bracket, you have to specify whatever number it is, say n, whatever it is. Coming to trigonometrical functions, this is very simple. I've used the square roots and the fractional symbols and other things. But when you're writing sine, tan, cos, or whatever it is, you have to give the slash sign. There is another example at the second example that is at the bottom, I have not used slash sign. I have just simply written sign. Okay, so you can see there is a difference between these two. The the theta is somewhat nearer to sign. Okay, it doesn't look good. So that is why I'm suggesting you when you're typing something, don't write the text, you type the command. If it is there, you type the command. That's all I wanted to show you in this slide. Now coming to another set of commands, that is summation, integration, limits. To print the summation sign, it's very easy. You give slash sum. And for the lower limits, you have to give an underscore symbol and you have to write the lower limits in this. That is k equal to minus infinity. So for the infinity symbol, it is infty. And for the upper limit, that is, you have to give an exponent symbol and write your upper limit in that curly brackets. And the other things are self-explanatory. C underscore k and E exponent minus j2 pi kf f naught t. For integral symbol also it is the same command, just have to replace it with int instead of sum. Rest of the things are same. For limits, it is also the same, slash lim underscore your limit, that whatever extends to 0. So for printing that arrow, I have used right arrow. I have long right arrow. So many options are there, left arrow, that you can go through. And then I have given slash frac for sin x by x and equal to 1. Now coming to functions and automatic brackets. So for writing a function, you have to give, anyway you have to go into that mode, that is begin equation. So I don't want a equation number, that is why I given an equation star. So f of x equals my left bracket starts, that is why I gave slash left and slash bracket. Then I want to print it in kind of a tabular form, that is I want 2 columns. So that is why I gave begin array and end array. You can use this begin array and end array for making a table as well, but it's not suggested. So for begin array, the command is the same like begin tabular. You have to specify the alignment of that column. So here I'm using left alignment. So the first row is x square, and in the second column, first column is x square, and the second column is if x tends x less than or equal to 0. For the less than or equal to symbol, it is LEQ. So I have written the if inside a text command. Why I have written like this is, you might have seen the sign what I have written in the previous example. It will be in italics form. So I want it in a straight form. That is why I have written it in text. Now I end it with, once I have written both my rows, and I'm ending my array, and I'm ending it with slash right. So I can put a bracket here, but our functions are not like that. Our functions have only one side bracket. So I have to give a dot here, saying that if I don't give a dot, there will be an error. So you have to give a dot saying that nothing has to be printed. You just have to close this with this right. For that alone, you are going to write this command. Now in the second example also it's same, it is self-explanatory. But what I want you to understand is, I have not specified the height of the array. So the bracket length, or I should say height of the bracket, it takes place automatically. Based on the height of the array, the bracket length will increase. Okay, you don't have to worry about it. In Word, it will be slightly difficult when you are going to type such equations in that. Now coming to matrices. Here also it is similar like an array, that is slash b matrix, that is a box matrix. You have to specify each column members and rows. And if you want a determinant or a vertical matrix, V matrix, you have to specify, and it's a command is the same. You just have to specify V matrix. So, any doubts so far? Do you want me to explain anything more on equations? Do you want me to show anything? Okay, fine. So we'll see now how to include figures. So we have seen styling commands, we have seen list commands, that is enumerate, itemize, we have seen how to include tables, and we have seen how to include equations in math mode. Now it's time to see how to include figures. So for figures, you have to use the package graphics. Okay, it's not there by default. You have to specify it in the preamble, that is between the document class and the begin document. You have to specify. It is not S, it is X graphics. Then only you can include a figure. So for the figure, it is similar to your table. Is you have a begin figure, and you have to specify your placement of the figure, that is HTB. Then you want the figure to be at the center of the page. That is why I have given slash centering. If you don't give this, it will be left aligned. That is by default. Then you can give a label for the figure, that the same way you have given for table. Then this is the line which you are going to use for inserting your figure. Slash include graphics. And in the optional brackets, you have a scale parameter. And in the curly brackets, you are specifying the figure name, that's the file name, and where it is placed. Now you can see this figure is actually very large. Okay, since I wanted to put it within this slide, I had to scale it down by, scale it down by 95%. Okay, actually it's just 5% of the actual size. Now I'll show you another example using the same figure, but with a different option. In this, I have used the option width. So you have line width and text width. Both are almost the same, but it will change according to your environments. So for this example, I have used line width. So what it does is, it will keep the aspect ratio same for the figure, but it will fit to your line width, whatever environment that you are using. Suppose if you don't have any environment, if you are just in the blank page, fit exactly to your page. Okay. Now I'll show you how this is done. Okay, I'll show you an example. So I'll use the same document. So I start with begin figure and slash centering, then include graphics. So I'll show you how large this figure is. I'll use a scale of say a 0.8. Okay, and my picture is in pictures folder, and my name is the file name is iphone.jpg. Okay, I'll show you where my picture is. That is in day 1 pictures. I have the iphone.jpg. So let me build it. See, there is an error. You can see the red line here. It shows undefined control sequence include graphics. This is because I have not included my package, that is use package graphics. Now if I build it once again, you can see my picture has come. but it's a very huge picture. You can see it is not, it's so large, it is gone beyond the size of the page. So let me reduce it slightly more, say 0.25. Now you can see it is still larger. Okay, so this is where the width command comes in. So if I use width equal to slash line width, you can see that it has fit exactly to the width of the page. There is an equal amount of margin on either side. But you can see this figure was written after my table, all the tables, but in actual output it is on top of all the tables. It is because I have not specified my positioning option. If I use HTB, it will be placed after my table. So this is very important. You have, if you want that picture to be where you want, you have to use it. So any doubts? Are you all clear? Fine. So I always suggest use the width option. It will make your life much simpler. You don't have to worry about the size of the picture. You just have to fit it where you want it. Now there are more options to explore. That means if you want multiple figures to be side by side with individual captions, I suggest you to use the package subcaption. And if you want to place watermarks on your pages, maybe in your thesis report or whatever it is, sometimes it may be required. So you can use ESO pick. It's another package. So these options I leave it to you. You can go through it, and it's rather simple. It's not that difficult. So we'll come to the next topic, that is bibliography. So this is actually a picture I have just cut out from one of the papers. So these are the references. This is how you see it in, all the conference papers, journals, all those things. So how to print them out? You can always type it out. I mean, you have two options. First one is the manual entry. So you can start with begin the bibliography and how many items that you are going to print it out. And you can start with /bib item and the reference, that like our label, you can have the reference for that and you can type it out. So you can see on the right side, this is the output. But this will take a lot of time, and you have to, in this example itself, you can see some things are aligned, it is italics, sometimes it is bolded, and there are a lot of things you have to enter. So it will take some time. So I have a second method. This is the frequently used method. It's using the bibtech command. Okay. For this, you have to use the package site, and you have the commands. There are only few commands. That is bibliography style. In this, I am specifying the IEEE transaction format. They have a different format. That is plain, assorted, otherwise assorted. All those things are there, but usually we use IEEE transaction or whatever way they want. Suppose a journal is specifying they want the references to be in this kind of format, you can use the format. Now, the bibliography command is where you specify the file name. In this, my file name is bib file. Okay, this is where you paste all your references. Okay, and then if you want to print out all the references, even though it is not referred in your or cited in your document, you want to print all the references, you have to give the command /no-cite. And if you want to refer a particular reference, or you want to cite a particular reference, you have to give the command /cite. And to make this references come in the actual output, that is in the PDF, there is a small set of steps that you have to do. So first you have to run PDF LaTeX. That means it converts LaTeX code into PDF. Then you have to run the bibtex command. So what it does is it will take the bib file and it will create a file, for its reference. That's what it does. And then you have to run the PDF LaTeX command one more time and one more time. Okay. Finally, to get all the citations in your PDF. And then you have to click view PDF. When you do that, you will get this kind of an example, this kind of an output. Okay. So I'll show you a demonstration I'll download one or two citations from IEEE Explore. I'll create a bib file and add the citations and how to build it using TechMaker and how to cite the reference. Okay. So first I'll make a new document. I'll save it. So I'll save it as day 2. So in this reference, this will be my file name, or say reference example. Now I start with document class, A4 paper, 12 point, report, begin document. I'll simply type something just to get my output. Now I have to use my package, that is the package known as set. I'll just build it once more so that no errors are there. Now we'll go to IEEE Explore. Okay. So in order to get some paper, I'll type power and I'll click enter. So if you come down, you can see there are a lot of conference papers. So I'll click on one of them. And to get this paper cited, you can see there is a cite this command. So you click this button, and this is the plain text. This is how the citation will be, but you don't want this. If you copy this, you have to align everything on your own. But you can see there is an option, bibtex. This is what LaTeX will understand. So you copy this, okay, or click copy here. Then come to your TechMaker, create a new document, and you paste it here. Now click save as, and this will be my bib file. So I'll name my file as bibfile.bib. You have to specify this extension. If you don't specify it, it will be .tex. So if you are mentioning it as a bib file, and click on save. Now here you can see there's a number. I'm going to change this number to say reference 1. This is for my understanding. For me, reference 1 will be this paper from this author, say whatever name it is. Okay. Now I go back to my reference example. Now I use bibliography style, IEEE transaction, then bibliography, that is bib file. Then I use no cite and star. Star means everything. That means whatever you have not cited or cited, it doesn't matter. It will print everything. So this was these 3 lines I have printed. Now we'll see how to build it. So first if you click on the quick build, you can see there are a lot of options here. LaTeX, DVI2, PostScript, PDF LaTeX. So we want PDF LaTeX. So you select this and you click on arrow. Okay, no error has come. Now the second step is you have to run bibtech. So you select bibtech and you have to click on run. So you should see that here, you should see that the process exited normally and there should not be any warning here. This command is what takes the bib file and creates the references. So if there is any warning, your reference won't be printed out. Okay. Now the next step is click on PDF LaTeX once more. So you can see one warning has come. Labels may have changed. Rerun to get cross references right. So I'll click on PDF LaTeX once more. And I have to click on View PDF. Now you can see my bibliography has come here. Okay, so it's similar to the styling that we have seen in IEEE Explore. Now, if you want to cite this, that means if you have seen any paper or journals, you might have seen in literature survey and other places that a certain paper is cited. So that square bracket with that one will be printed there. Don't type like this. Don't type square bracket one. You always use the command /cite. There is a /cite p. Don't use that. Use cite. Now, for you to remember each and every reference in your bib file, it will be difficult. And there is no auto completion for this. To get the auto completion, you save it and you close your TeXmaker. Then you open the TeXmaker once more. Then you open your bib2 reference example, this is my tex file, and then you start typing /cite. Now you can get the auto completion option /cite ref1, and you give PDF LaTeX and view. So that square bracket 1 has been printed. So this is how you get the reference for this is how you cite the reference in a bib file. It's very easy, but you have to be careful when you're running the bibtech command. There should not be any warning. People used to miss it, and finally you will not get any references. You will not get any citation. If you are referring something which is not there, say /cite ref2, you will get a question mark here. So this is how you will understand that your reference has not come correctly. So any doubts? Do you want me to show again? Okay. So I'll give you some tips for creating this using this bib file. First, download all your necessary citations. Anyway, when you start your project or thesis, whatever it is, you might have already downloaded all the papers. You might have taken your printouts and you marked, yes, I'm going to use this paper. I'm going to refer this paper in my thesis report. So first you download all your citations and place them in your bib file. And with minimum content in your main document, that is .tex, and referring the bib file like what we have done, run the bibtech command. Ensure that there are no warnings. If there are, fix them in the bib file. Hardly there will be any warning, but if there are, fix them. It will be small issues, like suppose you are writing a percentage that or something, I cannot show you now. Sometimes it comes. And if the auto completion for references are not displayed, close the TeXmaker and open it again, as you have seen now. And first, before citing everything, you make sure to use no cite command first and see that all the citations you have entered are coming in your references or the bibliography. And I'll stress it once again, getting the references in the document can be tricky. So please be patient. So this is for today. This is what I intended to cover for today. Tomorrow we'll see the rest of the things, how to include contents, how to include figures, list of tables, and other things. Any doubts?
Participants, if you have any doubt, please feel free to ask him.
Okay. So I don't think anybody has doubts. So shall we see tomorrow?
Yes, sir, we can. So
Okay,
thank you
fine.
for the session.